good evening, everybody. So we are from Group 1, and today we're going to talk about our case study in the form of presentation. So before that, I want to introduce the members of Group 1 of this computational thinking class. So first of all, there's going to be me, Raditya Abbydharma. There is also going to be Kanaya Salma, and there's also going to be Pramadipta Vasska, and lastly, there's going to be Syahrul Ahmad Hasan. So in this case, first of all, I'm going just to talk about the overview of the case study. So this case study is about the traffic light management at an intersection. So the road intersection has 4 entry directions. So there's going to be north, south, east, and west in each direction. And in this study case, we have to think about a system using the pillars of computational thinking to make a flowchart and also pseudocode, and also do analysis of the big O notation. So the main task here that has given to us is that to design the traffic management system using the approach of the 4 pillars of computational thinking, create a flowchart for the problem solving process, write a pseudocode for the problem solving process, and lastly analyze the big O complexity of the pseudocode. So please enjoy, and also we're going to do the presentation separately, but in this video it's going to be as a one big presentation. So just to know that. So yeah, please enjoy our presentation, and please move on to the next.
This is Syahrul. Today I'll be discussing on how we could approach a problem that is to create a traffic light management system that optimizes traffic flow using the 4 pillars of computational thinking as our approach. First, we have the decomposition. It is the part where we break down the problem into more manageable components. In this case, I separate into 5 separate components, which is weather, traffic density, road capacity, emergency vehicles, and the direction of the traffic light. Each of these components have an effect, whether positive or negative, on the traffic flow, and as such affects the duration in which a specific light will be presented. Second, we have pattern recognition. First of all, we have traffic density or road capacity. So in certain time periods like rush hour, traffic density or volume increases, and it can possibly exceed road capacity. This causes congestion. Now, to solve this, our system must prioritize traffic flow for these more congested lanes. Another fact is that traffic density also depends on not only the hour, but also on the day of the week. For example, on the weekend, since poor people are taking their vacation, and the roads will be used a bit more often, thereby increasing traffic density. Second, we have weather. Bad weather has adverse effects on road capacity, which causes congestion to occur a bit more easily. Third, we have abstraction. This is the phase where we simplify certain components in order to make a focused and accurate model of the system. The first thing that we simplify is the type of vehicle. We're using or assuming a uniform vehicle size. Second is road width or length or condition. Instead of measuring these on its own, we're only measuring the final road capacity as a result of these properties in the algorithm. Third, we have information acquisition. So things such as road capacity, traffic density, weather is assumed to be taken from a data point that is entirely accurate and is presented to the system without delay. Lastly, we have algorithm. In this case, there are 3 specific checks that are being done. First, it's to check for the weather. If the weather is bad, for example, if it's raining, then this would obviously reduce the road capacity, which means that the duration of the green lights must be increased, in this case by 10 seconds. If the weather is clear, we move on to checking if traffic density exceeds road capacity. If it does, then we have to check if it's severely dense or simply just dense. If it's severely dense, then we increase the green duration by 30 seconds. If it's only just dense, for example, if it's below, let's say, 50% or 70%, we increase the green light duration only by 15 seconds. If it is not dense, or if it doesn't exceed road capacity, we also have to check if the traffic is severely light, say below 20 cars per minute. If yes, then we reduce the green light duration by 15 seconds. If no, then we make no changes to the duration, since congestion does not really occur, and there is no need for us to adjust the default time duration for each light. And then after we have done that, check in which direction is a green light given. As it is a four-way intersection, in each instance there's always one green light and three red lights in all the other directions. Now, in the initial directions turn, we shall turn on the green light based on the previously determined duration, based on the condition of traffic that is done or mentioned before. After this initial green light finishes, we move on to the next direction. And this is done until after the final direction's green light finishes, and then this entire sequence is repeated again back to the starting direction. After that, the sequence is ended.
So in this part, before that, I want to reintroduce myself. My name is Raditya Abbydharma. I'm from the Metallurgical and Material Engineering batch of 2023. And in this part, we are going to talk about the flow chart for the study case. In this case, the study case is about, again, I want to reiterate that the study case is about the the problem with the traffic lights in an intersection. So in this part, in this problem, we are trying to approach the problem using a flow chart. So I'm going to explain the flow chart. So first of all, we are going to start to create an array. So this array will be the base for all, since the intersection has four ways of vehicles coming, or four lanes. Then there's going to be four of traffic lights. In this case, TL is traffic lights, so we're going to make an array with inside of this array is going to be 460s. These 460s represents the amount of seconds, or the amount of time that the light will turn green for each lane. So in this case, if the light is not green at all, then the light will be automatically red. Okay, so the next we are going to create an array for our rush time, or rush hour. Rush hour is going to happen in the morning, in the noon, and also when people going back from the work, or evening. So if the time or the hour is going to be a rush hour, it's going to be 7, 8, 9, 12, 13, 14, 17, 18, and 19 hour. And then we're going to set up some variables. In this case, we choose some variables that are pretty relevant to the problem. So first of all, there's going to be traffic density, or trafden. There's also W, or the weather. There's road cap, or road capacity, which we set up as 50. There's going to be EM_VE, or emergency vehicle detected. And then I is the element of the array TL. So we are going to use the element on the array to choose which one of the traffic light will turn green, unless they will have the TK for a technician key. So the technician will be the master owner of the traffic lights. So in this case, first of all, we're going to set I equals 0. This is important step, since the I is going to choose which lanes will have the green light first, and then it's going to input variables from data from the traffic camera and sensors. So as you can see, the traffic density, the weather, the emergency vehicles, and also the rush hours will be checked. And first of all, it's going to check if there is a technician key, or the technician key is going to be present. So in this case, if it's yes, then the traffic lights, all of the traffic lights will go off. So this is going into the maintenance mode, but of course we want these things to run, so the TK is going to be no in this case. Then we can move. So it's going to check any emergency vehicles, showed that any emergency vehicles, then the amount of green light will be extended for 10 seconds, and then if not, then there's going to be no extensions in the green light time. And then it's going to check for an actual hour. So what is the hour of the day? If the hour of the day, we're here going to use binary search, should that the hour of the day or the updated time is present in the array, so in this array rush time, then if it is, then the green light will be extended by 20 seconds. If not, then there's going to be non-extended. And then it's going to check the weather using the the variables w. In this case, yes. If it's yes or it's raining, then the amount of green light will be extended 10 seconds. So, and then if it's no, then there's no extension. Now we're going to check one of the most important parts. So this is going to be traffic density. So the road cap is going to be the maximum amount of traffic density that the lanes can handle. So should that the traffic density is more than the road cap, then it's going to check whether it's going above 70, since our setup for the road capacity is only 50. So should it go further than 70, then the amount of green light will be extended by 30. If not, then it's going to be extended by 15. But if the traffic density is going to be lower than the road capacity, then it's going to check whether the traffic density is lower than 20. Should the traffic density is lower than 20, then the amount of green light will be reduced by 50 seconds in order to making the lights more efficient, so the green light is not extended far more than it should be. And then after that, it's going to check for the eyes again. Since we first set up I at 0, then the east, in this case there's going to be east, south, west, and also north. So for 0, the east light will turn for the TLI, or the traffic light number 0 for seconds. So in each modifier of the TLI, then it's going to show up here. If it's going 1, it's going south, and it's going 2, it's going west. So if I is 3, then it's going to be an else. In this case, the north light turns green. So should after the output, that is the east, south, west, or even north, in this case, goes green, and after that the TLI will be reset back into 60. So in this case, the traffic lights will do another round of sensor and also calculation to calculate how much green light should they give. And for I equals 0 to 2, the I will be updated to 1 in order to change each lane, what lane goes after. So but after the I goes to 3, then we can reset it by here. So we again using a loop, in this case we reset the I into 0. So in this case, it's going to loop until a technician brings the technician key. So that's it actually about the flowchart. So in this case, we're just trying to approach this problem using some modifiers for each of the green light of each lane, so that we can improve how much green light time we're giving, and giving overall a more efficient value for each traffic light. We can continue to the next chapter. Thank you.
Hello everyone, my name is Vasca, and today I'm going to be explaining about the pseudocode of that we made from our flowchart. So first of all, based on our flowchart, we have to define a couple of variables and arrays. Namely, we have the TL, which is the traffic light, or as I should say, the green light times in each traffic light, and then we have the rush time, which is with the set amount of hours we have for rush hours. Then we have the traffic density, which we will get from the sensors, the W, which is the weather, also the sensors, the road capacity, which we will set to 40, the EMV wherein if we detect a emergency vehicle, TK is a technician's key, and time C is later on we would define to get the current time of the of the day, and we will compare it if it is in the rush hour or not. And we have set the TL, or the traffic light duration, for each, which is a minute for each green light. Next we will have a while loop for the green and red. So when the green light is off, we will turn on the red light. And then next we will have for each individual stoplight, we will have a for loop, which would increase from 0 until a maximum of 2, which is in the end of the for loop. So first off, we will get the data sensor from the data, and then it will first check if we have a technician's key. The technician's key main purpose is to end the loop early so that the technician could turn it off and then do maintenance. And if we don't detect that technician's key, then the code proceeds as usual, wherein it will first detect if there's a emergency vehicle or not, and if there is, it will increase the green light time by 10 seconds. Next, we will check if it's a rush hour or not by using a binary search to compare if the current hour is what we considered a rush hour or not. And the rush hour is an array which we have defined. And so the binary search itself is, while the left side is still less than or equal to the right side, we would then do a series of checking. First, we check the middle. If the median is indeed the current time, the current hour, we will add 20 seconds to the green light time. Otherwise, we won't. The code will continue. Next, if the weather equals true, what this means is, if the weather is rainy, for example, if we consider it as a bad weather, then we will add 10 seconds to the green light time. And then else, next we will check for the traffic density with respect to the road capacity. If the traffic density is greater than the road capacity, we will then check if it's greater than 70 cars per minute or not. If it is, we will add 30 seconds. If it's not, we add 15 seconds. That's what these two lines are for. And then else, other than that, if it's not greater than the road capacity, if the traffic density is not greater than the road capacity, then we will check if it is less than 20, or if the traffic density is less than 20. If it is, we will reduce 15 seconds from the time. And finally, we will check which iteration of the initial TL array it is. If it's 0, that means we will turn on the east light. If it's 1, the south, 2, the west and north. And then after all of these, we will go back to the for loop, except when it's else. And the else, it will set the I equals 1, which would restart the loop over again. And that is it from my part. Thank you for listening.
Okay, so for the big O notation for our case study, to start, we have to analyze the whole situation first. For example, we have to think what condition is happening right now. For rush hour, is it rush hour yet? For traffic density, is the traffic too dense? And for weather, is it raining? Is the weather bad? For road capacity, is the road capacity too high or even maybe too low? An emergency vehicle, is there an ambulance or any emergency vehicle? And so thus the conclusion is, for each and every condition that could possibly happen, if the situation is negative or not supposed to happen to the traffic flow, then action must be done. By negative or not supposed to happen to the traffic flow, we have to achieve in this case study, in this situation, we have to achieve the ideal situation for the intersection. And okay, I'm gonna move to the case study. we have a road intersection with four entry directions, and so we have to make sure there's no congestion, and we have to make sure that the flow is still going without any stops or slow movements. And then for the time complexity, it will always take the same time to run each and every condition. Each condition is checked once, and checking these conditions does not depend on how many vehicles or how much data we have. It is always a simple check. For example, is it rush hour? Yes. And is it raining at the same time? Yes. It is a yes or no question. From that, each action takes the same amount of time. Thus, the function runs in O1 time, meaning the time it takes to run does not change, whether the deal is with 1,000 cars or maybe just only 10 cars. It will always be a quick and fixed check. And the time is fixed whether the input is big or small. So, back to the previous slide. For rush hour, it will always be a 1 because it's a yes or no question. For traffic density, it will always be a 1 as well. Um, it will always be the same for weather, road capacity, and emergency vehicle as well. Or even um, some other factors that we don't write, like we have the type of vehicle. It will be O1 as well because, for example, like the question will be, is the vehicle big? Yes. Is the vehicle small? No. It will be a yes or no question. That's why every single thing that's gonna happen to the intersection, it will always be O1 as well. So everything plus O1, like O1 plus O1 plus O1, it's gonna be O1 as well.